Okay, so hi everybody. I'm David Bunch, and it's my privilege and pleasure to introduce our speaker today, Professor Stefan Eriksen Mabit. He's a visiting scholar here for about 6 months at UC Davis, and he's here on a Fulbright. He's an associate professor at the Technical University of Denmark, or DTU, and he's got an extensive research portfolio in travel behavior, transport demand, discrete choice modeling, and importantly for me, vehicle demand modeling involving alternative vehicles and electric vehicles, which is part of what he's going to be talking about today. He's very similar to me in a lot of ways. I mean, he's very strong on developing the methodology to collect data in things like discrete choice experiments, estimating the models, but also the applications are very important applications and have a direct impact on public policy. And all of those things are going to be, I think, in evidence in the talk he's about to give. So let's welcome Professor Mabit. Thank you.
Thank you, David. I'm proud of the comparison. To have similar interests as you. Thank you, and I will today give a talk with the title "Demand for Plug-in Electric Vehicles in the Future Danish Vehicle Markets," and it's based on some research I did recently. But before I talk about the research, I'll just introduce myself. Just talk a little about who am I and my research career. I was asked to do so, but I have tried to keep it short because some of you heard me speak 2 months ago, and I don't want to repeat myself too much. So a few slides on that, and then the main research topic for today, EV demand in Denmark. I'll try to introduce the context. You may not all be familiar with Denmark as I am, so I'll introduce the context before I move on to the research. I'm happy to answer questions along the way, so feel free to ask, especially instead of getting stuck on something I forget to say or explain. So first, a little more. So as David said, I'm a visiting Fulbright scholar here for half a year. I'm very happy to be here. It's a nice place. I'm invited. I was invited by David, and I'm hosted by Gil at the PHNEV Center. So I'm grateful to both David and Gil and the center. So at DTU, where I normally work, my work includes research, teaching, public consultancy, and applying for funding. Now that I sit with the PHNEV Center, I can see that I'm a lucky researcher. I don't have to apply nearly as much as they have here, but still, we have to do that as well. So my research focuses on sustainable transport, especially EV adoption and biking. Then I have also done research on travel behavior, especially related to mode choice and value of travel time estimation. And demand, what fascinates me the most is choice modeling and explaining choices, demand modeling, applying it to demand modeling. Currently I only teach transport modeling, but I've also taught choice modeling and statistics during the past 10 years. And then, public consultancy, I don't know if it's the exact same word you use here, but that means, we help the government and governmental agencies when they have questions. So a major thing I did, I worked on the national transport model from 10 to 18. Now they have a version running, but now they want to update it. So maybe I end up working more on it in the coming years. But that's, and then also the work I'll talk about today was work for the Danish Energy Agency. So that's also what I mean by public consultancy. So my research career, and so in 2003, I finished my Master of Science in Mathematics at the University of Copenhagen. I studied a year in France along the way. Then I did a PhD for 4 years. A PhD in Denmark is 3 years, so I I took a leave for 1 year because I got a travel grant where I could travel to University of Sydney, University of Chile, and EPFL in Lausanne. So yeah, so my 3-year PhD ended up being a 4-year study. And we only have, I mean, it's a different world than yours. We are like fixed. We are hired for 3 years and you are not extended. I mean, so people have to kind of hand in the PhD thesis after the 3 years. So of course, what you do is some people do instead, they become research assistants before becoming PhDs. So then you can kind of work on your research topic before. So that would be a way. And I was lucky then to get a 1-year leave during my PhD. So but this 3-year deadline is kind of rather strict. You can get a small minor extensions. So after that, I continue. My research career is not that interesting. I didn't jump around. I stayed at DTU for the past 20 years. But so I became assistant professor at DTU. You can say, why did I not do something else? I mean, in Denmark, it's the only place where I can actually study transport and do research. That, I mean, the combination of research and public consultancy related to transport, it's the only place in Denmark. But of course, so nowadays DTU has decided on a different policy. So they are forcing people to go abroad. You cannot really do what I did anymore. So if you want to stay in research, you're forced to go to another European or US or somewhere else in the world, at least as a postdoc, and then you can apply for a position and come back. And then since 14, I've been associate professor. So and during that, the last 4 years until 2020, I was also head of study of our master in transport and logistics, which is not as it's not that it's like 30 students per year, so it's 60 students we have on the master. So I don't know. That was my research career. Yeah, I don't know. It's of course different than what you have here in the US. So then a little bit about Denmark. So you just have the context for when I talk about the EV market and modeling electric vehicles in Denmark. So it's a small European country up there, we can see. 5.8 million inhabitants, a GDP per capita close to California, but not exactly the same. With car ownership, we are a lot lower. So we have like 2.6 million cars for around 3 million households. So a little less than a car per household. And you can see that we have like almost 40% of households without a car. It's mainly student household, I mean, single, I mean, a household that consists of a student. Because I mean, I didn't get my first car before the age of 36. So I mean, that's very common for people with longer educations in Denmark. So the per capita, I found out we are tying Ireland for the lowest number in Western Europe. And it's, close to, we only have 60% of what we have here in California per capita. So it's a different context than yours. But we are still in the transition. So we don't have as many cars we need to transition into becoming battery electric vehicle, but we still have the goal of 100% at some point in the future. So a main reason for this low ownership of vehicles in Denmark historically is that we have high taxes on the purchase of the first car. And I looked it up. Last time I might have said that we have the highest in the world. I have now found out Singapore also have comparable high taxes, but in Europe, we definitely have the highest vehicle taxes. So here you can see the schedule. So if the car has a base value from the manufacturer below 10,000, the value below $10,000 is taxed 25%. Then the value between 10 and 30,000 is taxed 85%. And the value above 30,000 is taxed 150%. So I think it's a taxation scheme invented in a country where you do not produce cars. So you don't want people to import too many cars. Then to support this green transition, they made this reduction for low emission vehicles. And in Denmark, they define low emission vehicles to be below 50 grams CO2 per kilometer. And then, of course, they had to make a lot of assumptions to make hybrids part of low emission vehicles, but they are currently, hybrids are counted as low emission vehicles. So hybrids, they get a 50% reduction as of 2022, and then it's decreased gradually towards 2035, where they will get 0 in tax reduction. For BEVs, I mean, it's a little higher now, it's 60%. It doesn't start to decline until 26, and then it'll gradually decrease until also disappearing in 2035. But this is one way of supporting green cars.
Is that rebate relative to the value of the car or value plus taxes?
It's the value, it's this registration tax. It's this part of the tax, not the sales tax.
Okay, so the rebate is all applied to that tax.
To that tax.
Okay,
Yeah.
okay.
So here you can just see in 2021 we saw there was around 185 new vehicle registrations. So 14% were BEVs and 23% were PHEVs. So last year it seemed like this tax reduction really somehow supported. People bought many more hybrids than what the government would have liked, and what the green transition probably also. Now we'll have a lot of hybrids staying in the market. But so you can see because of this reduction in taxes, we have had a huge increase in BEVs and hybrids the last 2 years. This last one is March 2022. So here you see, it seems like BEVs are still at a similar level as they were in 21, but for hybrids, we actually had a 5 percentage point increase in taxes. I mean, the reduction was removed by 5 percentage points. So, and that might be the reason why we see a small decline in PHEVs shares. Yeah, this is just because I was asked by Scott what are the most popular brands sold in Denmark. So these are the most popular brands sold last year of PHEVs. Just a final slide before I go to my research focus. This in Denmark, the official goal is that by 2030 we would like 1/3 of the vehicle, around 1 million. I mean, they like round numbers, so 1 million green cars on the street by 2030. That would be around 1/3 of the vehicle fleet. So this green line here shows how we reach that goal in 2030. So it's if the annual sales follow this line, we will the cumulative amount of green vehicles will go to 1 million in 2030. So here you can see the the actual sales here. So, and that's why people have started drawing other lines. So the light green would bring us to above the target. That would bring us up to actually 50% of green vehicles in 2030. But that's some people start arguing that we should increase the goals. And these are numbers cleaned of hybrids. So this is just pure electric vehicles. So yeah. But right now the official goal is 1/3 of all cars should be green. And right now green counts both hybrids and battery electric.
So is the policy only stated in terms of the total fleet, or is there a corresponding policy on the sales?
No, the policy is only stated in terms of the number that we would like 1 million green cars. And of course, they hope that it won't make the vehicle ownership explode. So, but they haven't formulated exactly a percentage. They've just formulated this round number 1 million.
Okay.
Yeah, what's the yellow line you have in the graph as well?
Yeah, that's like the expected decrease in the conventional vehicles, including hybrids. That would mean, yeah. So the research I would like to, focus on here is then some research we did. We started it 2 years ago and worked on it last year as well. So it's a national stated choice survey that we did in 2020 on behalf. Well, we worked together with the Danish Energy Agency to study vehicle demand when the vehicle market includes EVs and hybrids. So the first kind of results we have put in a paper. So it's a joint work together with my colleagues Anders Jensen and Mikkel Thorhauge and Jeppe, what I'm going to present now. So the motivation behind the study was that the Danish Energy Agency, like I have also heard over here, you have energy agencies and you have other agencies. They all want to be able to forecast the penetration of EVs into the future. So the energy agency in Denmark, they had a model, and it was based on like Anders's 10-year-old PhD results that wasn't fitted for what they were doing right now. So they wanted to update the model with. So they asked us if we could estimate a new model so they could get updated parameters. And there were also some things that they didn't have parameters for that they had kind of guessed and put into the model. So the model that they have is like an annual transaction model that forecasts the aggregate demand for vehicles in Denmark. So how many new EVs are purchased, how many new hybrids are purchased, and then in the old version, how many diesel and gasoline are purchased. And then, I mean, they also throw out some vehicles, and then they have the total amount of each fuel type in the Danish market, and they can predict how much energy are we going to use from each energy source. So we were asked to do this, and then in the new work, we decided on these 18 types of vehicles. So conventional vehicles, and now we collapsed both diesel and gas together. The reason is that diesel is not going to disappear in the Danish market, but in the new purchase, in the model of what people are going to purchase in the future, they expect it to disappear. So they will just have diesel cars in the model, but they will kind of slowly disappear out of the model. They do not introduce new diesel models or new diesel cars into the market. And then we have 6 segments, and you can see, yeah, that's the common segments in Denmark: mini, small, medium, large, premium, and then a very small luxury sports. Due to very high prices, it's very small luxury sports cars. And we have no SUVs. I mean, it's a flat country. The highest hill is 500 feet, so we don't really need SUVs.
We don't need them here.
Well, I just went to Yellowstone, and there I actually would have liked my car to be better at driving up and down the hills. Or not Yosemite. I went to Yosemite, and yeah, there I needed it. So the survey we made, it's kind of, if I split it up, it's 4 parts. So we had introduction and intro questions, and that we want to keep at a minimum, because the main focus of our survey was the stated choice experiments. So we wanted to keep the introduction, and before the stated choice experiments, we only wanted to ask questions that were needed to kind of tailor the stated choice experiments to the respondents. And then we gave the stated choice experiments. I will talk more about them in detail later. And then we had some background questions on the socioeconomics, and then we have attitudinal questions. So my focus today will be on the stated choice experiments. But to tailor the stated choice experiments, we needed to know, do you have access to charging at home? Because, I mean, the questions you ask to people, or the attributes, could be different depending on that. And then we also asked questions about the current car fleet that people had at home. And then we asked the question, how likely is it that you purchase a car within these 6 different segments? Because as I will show on the next slide, we have 6 car segments, and we have 3 fuel types. So in principle, we have 18 car types, you could say. And you don't want to present people with 18 alternatives. I mean, that's too much in a survey. So we decided that we would shorten it to the 2 most likely segments for each respondent times 3 fuel types. So they see 6 alternatives. And we did it in this way. I mean, you could do it in other ways, but so we asked them for each of the 6 segments, how likely is it that you purchase within this segment? And then we chose the 2 most likely ones, and in case of a tie, it was random. Yeah, and that's it. Might be it's an important decision how to, I mean, shorten it down from all these possible, and I haven't. I mean, right now we just assume that this is an okay way to do so. we found another paper by some Californian researchers that did the same. Carson actually did a similar thing, but we haven't seen it. Most of the time, people ask questions conditional on segments, and I haven't yet done the research to find out what is best. But yeah, it's a decision you have to make. So conditional on that decision, we then split the design depending on whether people had access to home charging. And we also decided that everybody should answer half the questions. They should compare BEVs to conventional vehicles. And then the other half, we had both hybrids, BEVs, and conventional. So that in total, we had 4 types of designs. Then we chose attribute levels based on realistic values for 2020 to 2030. So, I mean, they were both based on current and projected values because we wanted people to relate to the charging options they hopefully had in the future. If we restricted it to 2020 charging options, we would have too little variation in charging options. Then now it's a bit technical, so if you are not into stated choice designs, you can just, it will not affect how you understand my following slides. But I mean, so we designed them in Engine. And the variation in attributes was based on an efficient design. So that's just the way we made the variation in the values shown to the respondents with 0 priors. So the final design ended up with having 80 choice tasks, and we split them in 40 blocks. And then each respondent get 2 of these blocks. So 4 questions where they compare BEVs to ICVs, and 4 questions where they have ICV, BEV, and PHEVs. Yeah, but that's just the technical behind the survey design. So what respondents saw looked like this in one of the 4 design options. So here it's a person who has indicated that they prefer medium or large cars as their 2 segments. So they get a gas car medium, gas large, EV medium, EV large, hybrid medium, hybrid. And that's the 6 options they choose among. And then you can see to the left all the attributes that we use to describe the cars. So we have purchase price, operation cost, annual cost. We have range, acceleration, luggage space, CO2 emissions. And then we have the charging infrastructure here, which is only relevant for the EV and hybrids. So both EV and hybrid, if it's not possible to charge at home, we had the attribute, how are your options for charging at home? So we could investigate that. And then for the EVs, we also had the information about the kind of intercity charging network. So what's the distance between fast chargers on the main highway network, and how fast or how far can you go after a 10-minute charge on this? Yeah, that's the survey, main part of our survey. So the modeling approach, and again here there is a little technical stuff. If you're not a choice modeler, just accept it. It will not. You can still hopefully understand my results on the next couple of slides. If you do remember what either David or Giovanni has taught you in a course, then we use a panel mixed logit model over these 18 alternatives. Each respondent only has available 4 or 6 alternatives in the actual choice, but we can still construct that model as if it's over the 18 alternatives. And then specifically, we assume the respondents have unobserved heterogeneous preferences for fuel types and car segments. So yeah, specifically, this model is, some people call it error component mixed logit or random effect mixed logit. So we need to normalize something. So we normalize with respect to ICD and large. So we end up with a model with 7 mixing dimensions, or distributions, you could say. So the utility generically looks something like this. We have alternative specific constants for fuel types. Then we have a normal distributed preference for each fuel type. Then we have alternative specific constants for segments, which also has a normal distributed error component. Then we have generic coefficients on price and emissions and acceleration. And then for the charging and range, we allow for fuel-specific coefficients. And then we have the standard error term that's in the mixed logic model. So this was just the model. Now I move to the results, and that should be understandable even if mixed logit is exactly your favorite. So the sample we had was a backup sample. It's, I don't know, someone called it a backup sample, but in principle, we could just, it was people who were supposed to answer our national travel survey, but had not been asked because they had gotten enough answers already. So we had like an available sample we could just send out to them, and they were representative of the Danish population. So in June 2020, we obtained 23,674 observations, meaning choices. I mean, that would be individual. We have 8 choices per person, so it's 2,961 respondents. We had a response rate around 12%, so it's not that high, but hopefully it's close to representative. So in principle, the sample we invited was representative, but then of course some social groups have a higher tendency to answer than others. So when we looked at the final sample, we had an overrepresentation of males and an overrepresentation of people aged 43 to 62. While the geographic distribution seemed in line with the original kind of sample, so it was distributed across Denmark as it should. So here you can see the choices that people made in the survey. So you can see that we had people choose all 18 alternatives, but I mean, so if you look at the distribution across segments, we have the natural tendency that most people drive in medium and followed by small and large cars, and then mini, which is, I mean, it is small and medium that are the most common cars in the Danish market. Then for the fuel types, you shouldn't think so much about the fact that hybrid is lower. I mean, hybrid only answered half the questions. So naturally, it's on the next slide, you can see that when it's available, it has a higher share. So so this is descriptive split by the 4 designs that we made. And I think there are, even though this is at the aggregate level, there are some interesting things to see already. Just in our sample, 54% indicated that they would have access to charge at home. So 6% already have a charger available, and 48% thinks it's possible to put a charger up at their home. So the 54% who indicated it was possible to charge at home in the future, they got what we call the house design. So first they had the house design 1, where they chose between BEV and ICV, and you can see that most people in that case preferred the BEV, 57%. But then when we introduced the PHEV, I mean, hybrids steal from both ICV and BEVs, but I had to do it in Excel last night when I looked at this. So, but if you see how much they steal, relatively, they steal the same actually. While over here in the apartment design for respondents who did not have access at home, here you can see that hybrids, when they get introduced in the second half of the questions, they steal a lot more, or they steal relatively more from the BEVs than the ICVs. So it's indicating that at least for people without access to charging at home, hybrids is really an alternative that they use instead of purchasing a BEV, which of course makes sense, but in this.
Now, these are averages that are relative to the attribute designs that you used.
Yeah.
So, yeah, okay.
Yeah, but I still think the kind of the I mean, we vary with the same average across the 4, so they should have the similar.
So also
similar
the
levels.
averages maybe reflect what you expect to see anyway in the future, and then you vary around that.
Yeah.
Okay.
So And now I'll skip to the modeling results. A final technical comment is that, so we have this mixed logit model. We need to estimate it somehow. We estimated it in the program called Python Biogene. So it's we used 1500 MLHS draws, and we checked that after 1000 draws the results were like stable. So that's why we ended up with 1500. The final model has 66 parameters. All the important ones are significant with the expected signs. The reason I say this is we have a few. I mean, sometimes when you have 66 parameters, you add some of them at the same time, and then you do an accurate ratio test, and you see that the model extension is significant, improving the model. But then in the end, you look at all your parameters, and then a few of the parameters that were added, they were insignificant. We decided not to remove them. I mean, it's a bit technical, but we have like a full correlation matrix between our error components, and some of these correlations are not significant. So that's all the, I mean, the main effects of all the attributes were significant. So for results, instead of presenting a big table with all the results, I decided to split it in the different effects. So I'll have an effect, a slide on each of these effects. And we have, if I might skip a few effects if it takes too long. But so the first effect I would like to focus on is the cost effects. If you remember, we had 3 cost attributes. So we had purchase price. In the model, it becomes significant. It gets a negative significant effect. We also find that high income respondents find it less important. They are less responsive to purchase price. It makes sense. Then yearly cost, it's more important for low income respondents, less important for high income respondents. And then operation cost, we only found an average effect for the population or for the sample. And in fact, operations cost, I mean, it was both our impression and also a comment of a reviewer on the paper that they are difficult to capture in both in RP and SP data, maybe because people, I mean, they're just difficult to capture. When we ran our pilot, we couldn't really find a significant effect of operation cost, so we had to kind of think about how we presented it. Then it became significant here, but we couldn't find any significant interactions. So then, because we have 3 effects, we can find the willingness to pay for 2 of them. So we derive willingness to pay measures with respect to purchase price. So for each of the other attributes, we find out how much more would you be willing to pay when you purchase the vehicle to reduce one of the other attributes. So for yearly cost, we find a value of around 19, and that's, I mean, Danish kroner per annual Danish kroner. You can replace that by US dollars. It's the currency in both numerator and denominator. So a trade-off of 19, which is, if you study this literature, it's rather high. So that's, I mean, but that's I would say it's the only trade-off we get that's not realistic. So I had expected, or I did another study 10 years ago where we found 4, and the literature, not so many studies have this in them, but you can find a few studies, and there you get 4 to 5. David Green, I mean, who has written reviews on this, he would say also that around 4 is what the industry in the US expects consumers to be willing to pay for annual savings. Then operation cost, we get a value of 88,000. And again, you can just replace Danish kroner by US dollars. So, but 88,000, I mean, that would be a reasonable value if you allow for some discounting. I mean, it's less than the amount of kilometers you expect the vehicle to drive over the lifetime. But yeah, so that's the 2 results we get with respect to cost. Then for the range effects, for range, we were able to, for battery electric vehicles, we found a difference between households that had another car that was not a BEV. I mean, as David joked during the lunch, we don't have that many 2-vehicle households. And if we have 2 vehicle households, none of them have 2 BEVs. So it would in principle be almost all the 2 vehicle households where you have another car than the BEV you purchase, they have a lower willingness to pay for range than the ones where the BEV is the only car. We found the difference that if your BEV is your only car, then you have a willingness to pay of $85 per kilometer on average, and 62 if you have another car in the household that is non-BEV. Then for hybrids, they have much smaller ranges, so it was specified differently. It was specified as a log dependence, so you get a kind of a decreasing willingness to pay. So for a hybrid with a range of 25 kilometers, we got a willingness to pay of 286. If it had 50 kilometers, we found 143, and if it had 75 kilometers, we found a value of $95. So a lot higher, but on the other hand, relatively, your 1 kilometer on a 25 kilometer battery is relatively a lot more. So then for CO2 emissions, we were actually, we were afraid that CO2 emissions, it was not the focus of our study and it was somehow drowned among all the other attributes, but we did find significant negative effects. People at least seem to react a little bit to what we told them about CO2 emissions. We found that younger individuals and males were more sensitive. Young individuals is very common in the literature finding, while the male result is not that common. Then when we derive the average willingness to pay, we find that it's $76 per saved gram of CO2 per driven kilometer. And that's not really something most of us can relate to. I'm not an expert on this, so I couldn't relate to it. So I had to do some calculation to relate to it. So making some assumptions that a vehicle is expected to drive 150,000 kilometers, and if we don't depreciate and stuff like that, then it becomes something like $14 per ton CO2 saved. And here I think I have, when I translated it to dollars, I made a minor mistake. I actually think it should be 12 here. I have copied the 40, so it's 12 here. But the fact making this somehow something we could relate this to is then that the current valuation that we use in transport appraisals in Denmark is $14. So we found $12 and it's 14. So you can say, well, it's in accordance with what we actually do in Denmark right now, but on the other hand, it's not in accordance with what people think we should do it. We have, and it's not only environmental groups and similar agencies. It's also the official economic advisory board of the government. They are suggesting numbers like we should pay $227 per ton CO2. So it's a lot less than what some people think we should move towards within a few years, but it's in line with what we currently do. Then on the charging effects, we get $11 for each meter of a charging station is closer to home. $95 for each kilometer driving range. For each kilometer extra obtained by 10 minutes of charging, fast charging. And then we have some two effects that are very large. So, and this is the availability of charging. So it kind of shows me that that's one of the important things in this whole matter. So for people who do not have access to charging at home, we find that if we told them that they had if the closest charger to their home was available 1 or 2 times out of 4, they come down to charge. It's valued a lot less than if it's available 4 out of 4 or 3 out of 4 times. So the difference, we quantified it, and the willingness to pay for this, we got 13. a value of $13,000 if it's available 3 out of 4 times you get down to your local charger, and $19,500 if it's available every time. If you do not have charging at home, but it's available every time you come down to your closest charger. Then a last thing, which is not exactly a willingness to pay, but it's still a very interesting result, is the difference between these people who have access at home to charging and not access at home. We found if we transfer the dummy, we estimate between these two populations in our model into a willingness to pay, or into a, you could say, into a monetary difference. So we find that people with access to private charging or home charging, they're willing to pay 24,000 more for the same BEV as people who do not have access to charging at home. So we find a huge, and it's then $15,800 for PEVs or for hybrids. So we find a huge difference in willingness to accept or purchase BEVs and hybrids, depending on whether you have access to home charging or not. Then systematic preferences, I think I'll skip that unless someone asks in the end. Substitutions effects, very quickly, we estimate all these error components, and they indicate how the unobserved heterogeneity, if there is any correlation, unobserved correlation. We find some, we find out that if you prefer a BEV to ICV, you also prefer a hybrid to ICV. That's kind of nice to see, that you would expect that. We also get that if you prefer a mini, a small or medium to a large car, you prefer the two others. And then we also, definitely not at the same level, but we also find small correlation between BEVs and minis, and a negative correlation between hybrids and minis, but that's a lot smaller than what we find within fuel types and within segments. So the final result thing I would like to talk about is on elasticities. And here I don't know how many of you have worked with stated choice data. Not so many, but I can tell you that, if you are going to do so, if you want to calculate elasticities, those of you who have done it know the same as me, that you should be careful, because elasticities depend on the scale in the model. And the scale in a stated choice, you don't know the scale because it was stated choice. So you need somehow either to argue that your scale is correct, or you need to calibrate your model to something else. So the decision we made was to create a new data set where we only had average attributes on each alternative, because those were the ones we kind of had looked at in the first place, to say these are the projected values we expect to be realistic from 2020 to 2030. And then we decided to calibrate the alternative specific constants so that we reproduce the actual market shares for 2020. So our elasticities are of course dependent on this calibration, and it's a very, you can say it calibrates our model to a very low market share for EVs and hybrids. So in that sense, our elasticities should only be considered as realistic elasticities in the case where you are in the early part of the transition. And then the way we found elasticities, that kind of a standard way, mixed logit, we simulated the probabilities in the base case, and then we increased price or range with 10%, and then we calculated the shares again, and we derived the elasticities used this standard formula. So the elasticities we get, it's only for price and range. So you can see the elasticity for purchase price, for instance. In general, they are larger for purchase price than range, meaning that relative increases or relative changes in price will lead to a larger relative effect on demand than if you change the range. For instance, you can see with BEVs, if we increase the BEV price by 100%, we get more than 100% reduction. Well, that can happen, but still, you have an elasticity of minus 1.2, while for the BV range, we only have a positive direct elasticity of 0.5. So in general, price, it's more responsive to price than range changes. We get approximately the same direct price elasticity for BV and PHEV. And then the final observation is that, which is natural as well, driving range is more important for BVs than hybrids. You can say we didn't need a model to tell us that, but it's always nice if your model reflects your intuition. And then finally, because we have all the car segments in the model, we can also calculate elasticities among the different segments. And here you see also what your intuition will tell you that if you switch away from a medium car, you switch to mini, or if you switch away from a small car, for instance, it gets decreased here, you're more likely to switch to medium or mini than all the others. That makes sense as well. So I just want, after all these results, and this has nothing to do with the research, just one slide on how they used our model, the Danish Energy Agency. So in principle, they could not use all the fancy stuff we put in our model. So they had to cut away some of it. So when we estimated the model we worked with in our research, we tried to keep in mind what they were going to need, but at the still we wanted to go in directions that they then could not use. So they did implement a mixed logit model. So in that sense, they got a more elaborate model, you could say. Some now I think they are a bit frustrated about it because it's more complicated to they also have stakeholders and they need to explain the model that they are using. So, but they had to cut away our systematic heterogeneity. They couldn't include that in the model. And then they had to add an important component. When you estimate stated choice models, vehicle choice, it's very difficult to take into account the fact that you have, right now in the market, you have more variants of conventional cars than EVs. And 2 years ago, it was even more so. And in 5 years, it might be the opposite. But the number of variants you have of each fuel type, that's important for how the supply is important for what people purchase. So they had to include it in the model. So in the utility, they added a beta times log number of variants. And I mean, they decided after discussions, they decided on a coefficient of 1. It's very difficult to find literature supporting this. So really, with this choice set of 18 alternatives, I mean, I have literature where I have 1,000 alternatives. I mean, where I estimate a model with brand and model make and variant. And then I found the beta of 1. But we couldn't find a setting where you just have these. I think it depends on how many alternatives you have. Okay. So this was the best we could find, but I don't think I think it could be, if they could estimate an RP model with 18 alternatives, they would get a better result, I think. So, and then I don't know, depending on how you view it, I mean, I spoke with them after they implemented our model. And what they said was, it was a very nice model, we delivered, they liked it, but in the end, when they did their scenario analysis, what it came down to was the decisions they made on the alternative specific constants and this log variance. All our attributes on price, charging networks, it didn't matter that much in scenario analysis. That's, but they still have it and they can analyze all these different aspects, but it tells you something about, you can do fancy research models and then they will have to make some assumptions when they implement it and they might just drown all the details you try to estimate. So, I had some final discussion here. It was just, I wanted to just very briefly say some future work I would like to do on this data set we haven't looked at is, I mean, how does this selection, the fact that people have to choose, indicate two car segments, and then we reduce the choice set. I mean, the effect of this, what does it mean? And here I'm waiting for work by Priya and David. I'll see if they solve the issue for me before I work on it. No. So I hope to look at that as well. And then one thing I would like to look at as well is also spatial differences in PV preference, because even though I come from a small country, we still have regional differences. So I had this one figure showing you. So this is EV ownership in Denmark, split on regions, 10 regions. And you can see like the red and the blue and the purple up here, they are 3 regions where we have higher, I mean, this is in ownership, it's very low shares, but it's still a lot higher than in other regions. So that's the capital area and the 2 neighboring regions around the capital where we have higher EV ownership. And then you can see here, this is the second largest city, another university city with the, and then you have kind of the other regions down here. So a next research question is to investigate, because we find similar patterns in our stated choice data. Can we explain using our stated choice data where we see the same patterns, why people what factors is it that drive EV adoption in the large city? Yeah. So final comments. Well, I would just like to thank ITS and David again. It's very nice being here. And I'm actually today I'm halfway through my list. So yeah, but it's
Who's
nice
counting?
So, and also the PhD Center and Bill for hosting me, and Fulbright for sponsoring me or supporting me. Yeah, and I don't know if any of you have any questions. I'd be happy.
They do. Okay, it's time for questions. Kelly?
Yeah, I have a question about the attitudinal section, because it's actually kind of a 2-part question. Because like an important part seems to be access to at-home charging, but is there any way well, because some people might not be familiar with BEVs or how they're refueled, so is there education embedded in the survey as to how they're recharged in the first place?
No.
Okay, because it seems like some respondents may not know whether or not they have access to charging at home.
Yeah. It was 20% who wrote.
Oh, who said they don't know?
Don't know, and we just put them in the not access to charging at home segment. But I mean, maybe they should be treated differently. Actually, we right now it was 20% that answered don't know. But our argument, we just put them together with the apartment people who do not have access, because we thought it was more likely that people who live in apartments or housing where they don't have access, right, don't know because they don't.
Yeah.
know. Wasn't, but you said it was, did you have 2?
Oh, well, is there a question about their overall familiarity with PEDs?
I think one of the, not exactly, but one of the attitudes, there were both attitudinal questions and yeah, one of them was how many people do you know with EVs? I mean, that was part of the attitudinal questions in the end. So you can call that familiarity. We haven't looked at that.
So what does the mini segment look like in Denmark? It's not something that I'm super familiar with in the US context, so.
Yeah, I mean, out of my head, I would say as a Citroën C1 or a Peugeot 105 or a 108 or what they're called now. So all those, the smallest one in all the European. So I mean, if you look at the Peugeot or a family, it kind of, and the Citroën, they kind of indicate by the number the segments. So 10 something goes into mini, and 20 is small, and 30 is medium, and 4, 5.
But how many seats are in the mini? Is it?
It's still a 4-seat.
It's still a 4-seat car. Okay.
Like hatchbacks?
Yeah.
Yeah, it's a hatchback, but it has 4 seats, maybe only 2 doors.
So bigger than a smart car.
Yeah, it's bigger than a smart car. We don't have, I think because of the taxes in Denmark, they somehow didn't. So we only have very small but normal cars. I don't know who's first.
James.
I have one clarifying question just about the choice experiment. You have emissions for the BEVs. I was just wondering, is that based on the carbon intensity of the grid, or
Yeah, so we assumed, and I think we assumed 70% renewable energy in the grid. And then so they get some emissions.
And then on the finding of higher monetary value for BEVs by the people who have home charging, why do you think that is? Could it be something to do with their perceived, their perceptions about owning a BEV while having home charging relative to those that don't, or what?
Yeah, I mean, I think, I mean, it's kind of just a difference in we're kind of just monitorizing the demand difference between the two populations.
Oh.
So maybe I should have formulated it differently. I think if you come and offer to the same people just living in these two different environments, the same EV, then one of them would have to be subsidized that much to have the same probability of purchasing it.
I see.
So it's just I think it's just a question of people with access to home charging just see a life with a BEV as much more probable or possible in a country where most families is a one car family. I mean, I think the apartment people just see it as problematic if they cannot see where to charge, and that then transfers into a monetary or some kind of penalty that we then try to monetize, even though you can say it's not strictly a willingness to pay, because you cannot really move you do not move a person from being without access to charging to with charging if they live in an apartment. You can do that in a house. So it's just more a difference between the willingness to accept BEVs in the two populations, and I think for me it just highlights the importance of, if you want to go to 100% BEVs, you need to realize that you have I don't know, in Denmark it might be 30 or 40%. That for them it's a lot more problematic, because if they only have one car, I mean, to transfer to a BEV, you need both to think about the charging infrastructure in the cities where they live, and also maybe to subsidize different.
Thank you.
My question is related to that.
Could you speak up?
Yes, my question is related to the policy of taxation and how well people know it, because I was thinking maybe some people that are not willing to pay or not get the car maybe don't know well, the benefits of getting it. So I want to know like how people really know about this tax exception for the cars. That's one. And then the other one was if people know where the money of those taxes go, and if it goes back into maybe providing better electric infrastructure, and like if you could tell us more about that.
So the answer to the first question is people don't, I mean, if you ask half of the Danish population wouldn't know the vehicle taxes I explained to you. They just, I mean, in Denmark, we don't have prices and then you add a tax. We just see the final price. So they would just go down in the car store and see that EVs are not as expensive compared to an IC. So they wouldn't know the reductions. The second thing is we don't have separated out taxes in Denmark. I mean, so we have I think in Denmark it's like 2% of GDP comes from vehicle taxation, not only the one I spoke about, but also insurance. Insurances are taxed, and annual taxation. So we have we get $5 to $6 billion a year in vehicle taxes, and they are just part of the budget. So there is no kind of designated area where they go.
That clarifies your use of the rebate terminology,
Okay.
right?
Yeah.
Because I was looking at these separate big figures, but
No, we don't.
nobody sees that. So it does look like a rebate
Yeah.
on the top level price.
Yeah.
Yeah.
Yeah. It might go to support PhD students doing research. Completely different.
So, more questions?
Could you
go back to the elasticities and talk a little bit more about that.
To what?
The elasticities, like
Yeah.
look at by how a component is apartment. It looks pretty similar.
Yeah, that was why I didn't mention it, because they look similar. Yeah, so we split the calculation because, I mean, they had, in the model, there is a dummy that's kind of rather significant as we spoke about, but when you look at elasticities, they are fairly, so it seems like it's a level difference between the two groups, but the kind of the responsiveness is similar. So I think that's the conclusion. I mean, yeah, looking at the numbers, they seem fairly similar. So it's just they are at two different levels, but you can increase it similarly. You can get similar reactions of changing price and range.
Let's go back here.
Could you go back to that like final slide where you showed how the Danish government was implementing the model and like what the beta natural model
okay, that one.
term was? I don't think I quite understood.
Yeah, what,
This one.
can I just, you have different numbers of makes and models for a vehicle class. And the more makes and models you have in a given vehicle class, the more expected utility you have for that class as a whole because of that, the diversity of the choices within that class. And that's what that's about. Are you with me?
As in like if there are more makes and models in a specific, like in say like conventional vehicles, what do you mean by like better utility? I mean, like,
Well, what I mean is if you have more makes and models, this is a highly differentiated product, right?
Yeah.
And so within a vehicle class, there are going to be all these differences across these makes and models.
Right.
Maybe you like a brand better than some other brand,
so
right?
trying to capture all the like
It's-
minute other details.
So there's more choice.
Yeah.
There are more, there's a bigger portfolio of choice and more options. And so overall, as a class, the expected utility that you would get from buying a vehicle in that class is higher. Because of the diversity, there's more diversity of choice. Yeah.
Yeah. So yeah, that's it's kind of a technical solution to not modeling more than 8. I mean, we know we are modeling a vehicle market of 1,000 cars and by 18 alternatives, and yeah, this is just one approximation to capturing all the diversity you have below that you're aggregating. There was one question here before.
Going to this part, so the people get select a group of choices depending on what they currently have or what they think they will have. So how do you, because you have 18, but you only show them 4 or 6 options, right? So how does the selection go to what?
It should be a kind of a mimic of their next vehicle purchase. So it's conditional on their. We ask them, do you want to replace or add? So of course, if they say replace, we see it as conditional on the ownership they have, removing the car they want to replace, and then they add a new one. And if they want to add one, it's just conditional on their current ownership. But we haven't really used that except for adding this variable on whether they have a BEV or a non-BEV in the household. That we have that information because they told us the vehicle portfolio they already have and whether they replace or add. Was that an answer?
So it seems like there's apartments have some sort of drawback that prevents people from committing to a BEV. It's probably access to charging, I figure, right? Is there anything that we can do to make sure it's just that issue, just like any research that could be done?
Yeah, I don't know whether they do it enough, but I think in Denmark they try to put up chargers close by people's homes, and right now they are trying to change the regulation. I guess you also have technical issues once in a while with regulation, but there were some regulation that municipalities could not decide on where to put up chargers. It had to be state decisions. So now they just removed that 1st of April. So now municipalities in principle are allowed to, you can apply to the municipality if you want to put up a charger close by if you are a small community of houses. Now you can do it more easily. So I think stuff like that. So in Denmark, I guess they subsidize it right now, but I don't know exactly how. I don't have other suggestions, but somehow supporting the rollout of local charging network. I mean, I think you have people being skeptical about how much money you should put into the intercity charging network. But I think the local, they at least, I think this, and I would expect it to be similar in other countries, that people who do not have access to private charging, they will have problems. But of course, it's less in the US if you can have more cars in your household. But if you wanted to go to 100% EV, you will have the same issues. I understand.
So I guess I have a question about sort of the household characteristics of Danish people and how, I mean, you illustrate some differences between people who are potentially in an apartment or they think they might not have access to charging versus those who are in household. I'm just curious, like, sort of, what's the sort of typical household sizes in Denmark? You have a lot of people living by themselves in apartments or in households of like two, and sort of how does that kind of correlate with the vehicle ownership?
Yeah, I don't have any numbers. Yeah, on average, I think there is one kid per family with kids, but that's not or per family. But I don't know how many single households we have versus. I would get a lot of the households without cars, the 38%, they are probably single households with living. But I don't know how much it's different than in California, for instance. Denmark is, we have like a capital with 1.5 million, like Sacramento, Copenhagen and Sacramento has the similar populations, great areas. And then we have a smaller city, Aarhus, with 300,000 people. And below that, you then just have 100,000 cities where most people will have cars. But in those, I don't know exactly what numbers. I mean, definitely we have more density and fewer cars than you have here, but whether we have more single or households, I don't know.
Is there anybody online?
There are a few online. Okay, so one question is, at present availability of charging electric vehicles is a limitation. How does a decreasing number of conventional vehicles impact the availability of fuel for conventional vehicles and therefore demand for conventional vehicles?
If I understand the question correct, I mean, right now we don't see any signs that decreasing demand for conventional fuels. I mean, it's not seen to affect the market as of now in Denmark. In the future, of course, it will happen, but I don't know. I don't have a good answer.
Okay. There is a few more. Another question. How should we interpret the differences between actual BV purchases and the preferences for BVs in the result?
I think that was what I tried to hint at when I discussed the calibration of the SP, and I think we did a calibration to 2020 where BEV demand was low, relatively low. Now that we have a 2021 demand that's higher, and maybe also a 2022, that if we calibrate it to those years, you would, I mean, the data where the SP was estimated would be a lot more closer to the calibrated, the calibration data, and then I think the preferences will not change that much. Right now they change a lot because we calibrate very tightly to a 2020 year where demand was a lot lower. So elasticities change a lot, I should say.
Another question someone has, how do you account for the effects of emission-based taxes on vehicles in Denmark? The phase-in of registration costs for EVs over the next decade. How much do you attribute these in your assessment of EV demand in the coming years? It might help to, if you want to read it, it's kind of long. How do you account for the effects of emission-based taxes on vehicles in Denmark? The phase-in of registration costs for EVs over the next decade. How much do you attribute these in your assessment of EV demand?
I mean, it seems like, if I understand the question correctly, it's emission-based taxes. I guess it's how the registration tax is based on emissions. It seems like they affected the demand in 2020 somehow, and it also seems like we have a decrease in hybrids now, that we had a 5% change in percentage point change in taxes, so it has some effect. But I don't also think a lot of other things are happening, like attitudinal change, or also the fact that the supply is changing. This one, I mean, in my experience, this means a lot. The fact that car producers in Europe, similar to the US, are forced to throw out a lot of EVs on the market to live up to the, here you call it CAFE, I guess.
Well, we have a ZEV mandate in
Okay, you have a
California.
7 man. Okay, so but similar stuff, they have similar stuff, and we have similar stuff in Europe. So all the big manufacturer groups need to put out EVs and hybrids on the market to live up to regulation, and that forces demand towards those. I think that's also a push in that direction, and separating them is not possible given the data I have here. I mean, that's maybe some other research.
Could I just get clarification on the assumption behind that question, which is, there isn't literally a tax that people pay where you say to them, oh, your car produces this many grams of CO2, and so your registration is this.
No.
It's more based on either vehicle size, it used to be engine size, right? And so these are basically taxes based on which segment you're in and that kind of thing, right?
Well, but now there is, like, if you are below 50 grams CO2 per kilometer.
Oh, there is that.
That's
Okay.
what I understand.
That's the penalty, okay. That's
That's
the fee, okay.
And if it's zero.
The half of a fee base.
Yeah, and if it's zero or counted
Okay.
as a zero, then so that's what I understood. So I think they make some of the push, but I think the politicians in Denmark want to give them all the credit because they decided on those rules. But I think the EU regulation pushing towards more EVs has just as much effect. Priya, you had a comment on?
If you've done the all online ones.
There's just one more, but you go ahead.
Okay, so it's related to the tax thing. You mentioned that it's not like the consumers don't really know like the tax difference across vehicle types. So has there been, it's not related to any, has there been any study that if you actually make those tax information salient to the consumer, like you actually tell them that you're paying more tax for an ICE vehicle versus BEV, has there been any study if that has an impact on consumer demand or not?
No, not that I know of.
Okay. Yeah, I mean, there will be some studies here, but related to more grocery store items,
Okay.
where like this tax salience has been found to have an impact. So like, that's why I was wondering.
Yeah, no, I don't.
Okay.
Okay, last question online. Did you study how the convenience of fast charging locations impact demand? For example, can people fast charge while eating, shopping, working, etc.?
We didn't do it in this research. We did it in an old study, but that was like in an old EV context in 13. And I mean, those results are definitely outdated now. Right? Well, no, we didn't do it here.
The challenge of doing these choice experiments, you can't put everything in. You can add a lot of stuff, but then it's unwieldy and the person is not going to be able to answer the questions, right? So, yeah. All right, well, any other last questions here? Or? Let's thank Professor Mabit.